Let's take a look at the binomial probability distribution. Now this is a distribution that is for discrete random variables, and we will actually have a formula for this one, not a table like we have in the previous ones. So first up, here's the features of a binomial experiment. So there's a fixed number of trials. So we denote this number of trials with the letter n, all right? So maybe we do this thing 5 times. Maybe we do it 20 times. So lowercase n, that'll be the sample size. That'll be the number of trials. Second thing, the trials have to be independent. So whatever happens on one trial does not in any way affect what happens on any other trials. The third one, this is why it's called binomial, there's only 2 outcomes, success and failure. Now a success is usually what it is that you're looking for. A failure is the opposite of that, what you're not looking for. We'll do an example in a minute. The fourth thing is that for every individual trial, the probability of success is the same. So the probability of success stays the same every time you do this. And we're going to let lowercase p be the probability of success, and then a failure by q, and success plus failure has to be a 1. So if you know the probability of success, like 80%, then q, probability of failure, would be 1 minus p, 1 minus 80%. And the main problem that we're going to be doing here is this. We want to find the probability of having exactly r successes out of n trials. Let's look at an example. Let's look at an example here. This is problem 18 in our textbook in 5.2, I think it is. So one-time fling. So have you ever purchased an article of clothing, worn the item once to a party, and then returned the purchase? All right, so this activity is called a one-time fling, and apparently about 10% of all adults deliberately do this and feel no guilt about it. And there's actually been a study by this person here. So here's what's going on for us. In a group of 7 adults, what's the probability that no one has done a one-time fling? And then we could ask others, what's the probability of exactly 3? And so on. So first of all, is this a binomial experiment? So what's up first is there a fixed number of trials? Well, yes, there is. There's 7, all right? So I'm going to write that up here. N is equal to 7. We're going to ask 7 of our adult friends. Secondly, are each of the trials, are they independent? So I think so, because if you ask one friend, have you ever done a one-time fling, and then ask another, one person doing it probably is not going to depend on another person doing it. So I would say yes to that. The third one is each trial has only 2 outcomes, all right, success and failure. All right, so I'm going to call a success, say, as they write it, doing a one-time fling. All right, so a success is getting somebody who has done a one-time fling, and a failure is not doing it. All right, so we've got the first 3. Now, what about 4? Number 4. The probability of success each time is the same. So what's the probability of doing a one-time fling for any one particular person? That's 10%, all right, so 0.10. So that stays the same for every person. So what we have here now is going to be P equals 0.10, and Q, probability of failure, well, that's going to be 1 minus 0.10. That's 0.90. All right, so formula coming up. Let's read through this. So if P, now this is supposed to be a lowercase p, so if P is the probability of success on a single trial, and Q is the corresponding probability of failure, so you've got a binomial experiment, P is the probability of success on a single trial, like in the last problem here, back over here, probability of success of getting a one-time fling was 10%. Probability of failure, 90%. So let's go through. If P is the probability of success on a single trial, Q is the probability of failure, and every time you do the experiment, P and Q stay the same, then, all right, then, that's a comma, then the probability, this is a capital P, the probability that you will get exactly, all right, exactly, not just close to it, but exactly R successes in trials is given by this formula right here. Now, R, that's just the number of successes that you're looking for. So if you do this thing, say, 7 times, like the 7 adults, maybe you want, what's the probability of getting exactly 4 successes? Now, because people write combinations different ways, this is how I like to write it. You might see this written like this. A combination of n objects take an R at a time, or you can write it, I think the book does it like this, C N, let me get an N there, N R. Or even, here's how the calculator does it. We're going to use the calculator a lot for this. N C R. So let's look at this formula here and make sense of it all. I'll do it right up here. So you may remember from a few sections ago, we took a look at combinations. The combinations, if you have n objects and you want to choose R of them, what you had was this. So I'll write it like this here. A combination of n objects chosen R at a time. You remember this formula here? The top was n factorial. All right, that's the number of objects that you have. You put that on top. And on the bottom, you make a division by this. It's R factorial, the number that you're going to draw, times n minus R factorial. Now R, this is the number that you want to choose. You want that number. And n minus R, that's the leftover. So this is the number that you want. This is the number that you don't want. So I remember it like this. It's a fraction. The top number is the total number of objects that I've got. The bottom number is a multiplication by the number of things that I want times the number of things that I don't want. Let's look at a numerical example. Suppose we want to compute, say we have 7 objects and we want to see how many ways we can choose 2 of them. All right, well, this is going to be, now what goes on top? The top number is n factorial. That's the total number of objects that we have. So for us, it'll be a 7 factorial. And then the bottom is R. That's the number that we want to choose. That's a 2 factorial. Times, look at this, n minus R. The total number we have minus the number that we're going to choose. So for us, it's 7 minus 2 factorial. Now that's going to give us 7 factorial on the top, 2 factorial on the bottom, and then a 5 factorial. And to compute this by hand, what we're going to do is, notice on the bottom a 2 factorial and a 5 factorial. We're going to take this top and break it down 7, 6, until we get that 5, the bigger the numbers. So how about 7 factorial is 7 times 6 times, and then 5, 4, 3, 2, 1 is 5 factorial. Then those 5 factorials cancel, and now we are left with 7, well, actually we can even do this. This is what? 7 times 6, now 2 factorial is just 2. And 2 will go into 6 3 times, so we end up here with 21. Now, back in our example, if you go back here, our example was this one-time fling. So what does it say? About 10% of all adults deliberately do this and feel no guilt. All right, so now we're going to have a group of 7 friends. What's the probability? And we ask each one individually, have you ever done this? So in our example, what we have is n is equal to 7. Now the probability P of success on a single trial is 0.10, and the probability of failure, right, probability of failure is 1 minus 0.10 is 0.90. All right, so let's do this one. This is not actually part of that problem, but I'll just make this up. What we want to do is find the probability that exactly 2 people in our group of 7 have had a one-time fling. Well, we want exactly 2. So in our case, R, the number that we're going to draw here, is 2. All right, so we want to compute this. What is the probability? Now, I like to write things in English first. Exactly 2 successes. I'll translate it to English. X is our random variable. What's the probability that x equals 2? All right, and this is going to be, all right, now here's our formula. The formula is 7, choose 2, that we just computed, times the probability of success, now look at the formula here, P, that's the probability of success on a single trial, raised to the number of successes that we want. Right? P is the probability of success on a single trial, 0.10 for us, raised to the number of successes that we want. Right? R is the number of successes that we want, and we want 2. So we're going to raise that to the second power, times Q, which is 0.90, raised to the n minus r. Now, n minus r, I'll go ahead and write it all out. That's going to be 7 total people minus 2 successes. So it always goes like this. It's the combination of n choose r and then times the probability of success to the number of successes that you want, times the probability of failure to the number of failures that you want. So down here, probability of success is 0.10. We want 2 of those. So if we want 2 successes, we must want 5 failures. So if we did this all by hand, we would get 7 factorial over 2 factorial times 7 minus 2 factorial, 0.10 squared, 0.90 to the 5. Now don't worry, I'm going to show you how to do this all on the calculator with just punching numbers in. So we're going to get 7 factorial over 2 factorial times 5 factorial times 0.10 squared times 0.90 to the 5th. This is going to be 7 factorial over 2 factorial. Oh, what are we going to do here? We're going to take that 7 and write it like this. 7 times 6 times 5 factorial over 2 factorial, 5 factorial, and then the 0.10 squared, 0.90 to the 5th. These 5's cancel. And we are going to get, okay, now let's just do this. We know what we get here, right? 7 times 6 is 42. Actually, let's do it all. 42 divided by 2, 21. So we get 21 times 0.10 squared times 0.90 to the 5th. So on your calculator now, type in 21 times, and then you can put in 0.10, square it. Okay, I used this key here. Right above division is that one, but you could also use the x squared key, right? And then you want times, so press the times key, put in 0.90, and raise that to the 5th power. Now, when I did that, I got this. I got the probability of exactly 2 successes, exactly 2 people out of those 7 saying they've had a one-time fling to be this. 0.1240, and I like to round probabilities off to 4 places. So I'm going to leave this as 0.1240, meaning about what? This is about what? 12.4% of those people have had a one-time fling. All right, now that's doing it by hand. So by calculator, first thing you're going to do is press the second key. All right, so you press second. Now the second key is right here, top left, row 1. I don't count that as a row. Row 1, column 1. Then you're going to press the VARS key. V-A-R-S. And the VARS key, okay, that's right over here. All right, it's right by the clear key. All right, I'm going to say it's in row 3, column 4. All right, so you press second and VARS, and what that actually does is that gets you, when you press the second, you're really getting distributions. Now, you have to scroll down using that down arrow key. Scroll down to letter A. So what it'll look like is this. A says binomial, and then there's 2 binomials. The A says binomial PDF, and then it's got a parentheses. So when you're dealing with exactlies, you want the P. This is for exactlies. All right, the B, we'll take care of a look at that one in a minute, CDF. All right, so you scroll down till you get to A, binomial PDF, press enter. So you press enter. All right, so you press that enter key, and the enter key, of course, is right here at the bottom right. And if everything went well, according to plan, you're going to get this screen here. It's going to say Binom PDF up on top, then trials, P, and X value, and then paste. All right, so here's what's going to happen. Your cursor is probably blinking right here, right? Your cursor is probably blinking. So we have, what, 7 trials. So you're going to type in 7. The P value, 0.1, right? Just 0.1. 0.1. The X value, 2. All right, so what we have out of 7 objects, choose 2. The P is 0.1. Now the calculator knows automatically what Q is. Calculator has this formula built into it. Now just press paste. So go ahead and just enter, press paste, and see what happens. So when you press paste, what it does, it pastes this information. The calculator pastes this information onto your computation screen. All right, so on your screen, you should be seeing this right here. Now, all you have to do is press enter. All right, so at this point, press enter. All right, so you press the enter key. And when you press that enter key, I'm coming back with this, 0.12400, 0029, and I'll round off to 4 places. So there it is, 0.1240. All right, let's go through this on our calculator here. So for part A, we want the probability that no one has a one-time fling. So no one. All right, now that means to me that X is equal to 0, right? X is the number of successes, and we want 0. All right, so what I'm going to compute now is this. I want to compute, I'm going to do it on the calculator. Here's what I want to go get somehow. Binom PDF, and I want this to be 7 trials at 0.1 or 0.10, and I want 0 successes. I've got to get that on my calculator somehow. So let's just remind ourselves how to do it. All right, let's recall what we're going to do. We're going to go press the second key. So press the second key. I'll do it too. Press the VARS key. Now, here's the VARS key. I'm going to go back a screen. All right, so the second key is up here, top left. VARS key is right down here next to clear. All right, we're going to start using this so often, you'll just know automatically where these keys are. So second, VARS. Let's go back. All right, so second VARS, scroll down to A. So use your down arrow screen, scroll down to A. So I need to do that too here. Scroll down to A. All right, and what you want now is you're getting Binom PDF. Actually, it doesn't say binomial, right? It says Binom PDF. In fact, I'm going to make that clearer here. It says, I thought it said binomial because I haven't done it for a while. It says Binom PDF, and it gives you a parentheses. All right, so that's the one we want. So press enter. Now, what comes up now is, you get that little Binom PDF at the top. Binom PDF at the top of the screen. Then it says trials, and we want 7. Then it says P. What's the P value? Well, ours is 0.1 or 0.10 if you like. Then it says X value. All right, the X value is 0. We want no successes. And then go ahead and go to paste, right? So put the cursor on paste and press enter. Press that enter key at the bottom right. Then what it does, it will paste this into your computation screen. It says Binom PDF at 7.10. Now all you have to do is press the enter key again to make the calculator perform that operation. And when I do that, I got this 0.4782 969. But I'm going to round off to 4 decimal places. So I'm going to round this up. Well, if I round that up, I get a 10. That goes to the 2. So I get 4830. All right, so I'll clean it up here. The probability of getting no one in that group of 7 is 0.4830. So it's almost a 50% chance that no one of your 7 friends will have done a one-time fling. All right, let's look at this part B. We can do this one easily, I think, if we have an understanding of complements. At least one person. All right, now I'm going to write it in English. This is where it helps me. At least one. Okay? At least one. Now, what is when I see at least, whenever you see at least, you might want to start doing this. What you want to do when you see at least is think the opposite. All right, so if I have at least one, the opposite, the way I see it, is that the opposite of at least one is none, right? You know, if I have something like this, here's one. What's at least one means all this. Okay, what's the opposite? Well, 0. That's the only thing left. Now, the way I'm going to look at that is like this. If I go back to my 1 unit of probability and say, I want to know what this is right here. What is that? Well, if I know this one, if I know that one, I can just take 1 minus what I know, and that gets me what I want. Right, like for example, if I wanted to know this one, and this I knew to be 0.7, 1 minus 0.7 would be 0.3. So I'm going to use this idea here. When I see at least one up here at the top, when I see the probability of at least one, I'm going to think the opposite. And as soon as I think the opposite, here's the opposite. It's 1 minus, all right? So I'm going to come down here now. I'm going to think the opposite. And I'm going to write 1 minus the probability. And what's the opposite of at least 1? None. Now, this is 1 minus. Now, we just happened to, in part A, regular textbook type problem, we just found this, right? The probability of none, that turned out to be 4830, right? So 1 minus the probability of none. We just computed that in part A. So regular textbook type problems, they give you A and then ask you about B, where you're going to use A. So 4830, oh, let me get it to right, 0.4830. So on your calculator, you're going to type 1 minus, right? So that's exactly what you're going to type, 0.4830, and I'm getting this to be 0.517. All right, so here's what we have so far. In part A, the probability of no one, that's going to be 0.4830. And then in part B, the probability of at least one is 0.517. Now in part C, we're asked for the probability of no more than 2. So I write it in English. Now what does this mean? No more than 2 means what? That x has to be, now no more than 2 means 2 could be included. So less than or equal to 2. Now I'm going to write this in terms of exactlies. So what does that mean in terms of exactlies? I mean, you can go directly here or write this one, the inequality. Here's what it means. X could be what? 0 or 1 or 2, right? That's less than or equal to 2. Now, these are mutually exclusive events, so they're pluses, right? I mean, if you get exactly nobody doing a one-time fling, you can't get exactly one at the same time. So these are going to be added. So what we're looking at is this. What's the probability that x is 0 plus the probability that x is 1 plus the probability that x is 2? Now, I could do this. I'll show you a shortcut in a minute, but I could do this. I could go through the calculator getting binom PDF of what? 7.1 and 0, right? 7 people, 0.1 success, and 0 successes. And then I come to this one. So then I get that in my calculator, and then I have to figure out how to do this. Plus, I'd have to get binom PDF of 7.11, and then this plus here, binom PDF of 7.1 and 2. Okay, that is really cumbersome. But the calculator has a way around this, right? So we're not going to do it that way. Forget that idea. What we're going to do instead is we're going to use B, which is binom CDF. And the C stands for cumulative. Cumulative. So what it does, it accumulates from 0 to, some number that we want. All right, so here's what we're going to do. On our calculators, we are going to go to second, VARS, and that VARS key is really that distribution. All right, so we're going to do that, and then we're going to scroll down. Oh, let's even say we're going to scroll down to B, and B is binom CDF. All right, so if you want exactly one, you use the PDF. This is if you want to accumulate, all right? It's an accumulator. All right, so you get binom, here you are. You're binom B. You're binom CDF. Get a parentheses. Okay, so you choose that one. So now you press enter. And what comes up now, I'll do it up here at the top. At the top now, you get a little expressions telling you where you're binom CDF. And then you get trials, just like before. Now trials, we still have 7. You get your probability of success, 0.1 for us. Now, what is the X value? Well, the X value, that's the value that you want to go to. So what we want, that's why I like to look at it over here, we want to go to 2, right? 0, 1, or 2. We want to accumulate from 0 to 2, right? Accumulate from 0 to 2. All right, so this is going to be 2. So we're going to go from 0, 1, and 2. This is going to make all of these individual computations, but it's a calculator, so it does them really fast. All right, now go down to paste and press enter. When you press enter on your calculator, this comes up on the screen, right? Binom CDF 7.1 and 2. Press enter again. You press enter again, and here's the probability, 0.974385. I'll round off to 4 places, so I'm going to say this, that the probability of getting no more than 2 is 0.9743. All right, so about a 97.5% chance that no more than 2 people in your group will have tried or said they've done one of these one-time flings. Let's do another example just so we feel comfortable and confident about this using our calculator. So here's an example that came out of Cornell research. So a research team at Cornell conducted a study showing that approximately 10% of all businessmen who wear ties wear them so tightly that they actually reduce blood flow to the brain. All right? So what we want to know then is, at a board meeting of 20 businessmen, all right, let's write this down as we go. Here's what we know. N is equal to 20. Now, what are we looking for here? At least one is too tight. More than 2 are too tight. no tie is too tight. We're looking for ties that are too tight. So what I want to do is I'm going to let a success be a tie that is too tight. All right, that's what I'm going to call a success. And what is the probability of that? The probability of success, it says 10%. All right, so then you know that Q is equal to 1 minus 10%, which is 90%. Same numbers as the last problem. All right, now what do we want to know here? We need to get R. So R is going to be different for these problems here, for different parts. All right, so here's part A. Part A says, what's the probability that at least one is too tight? Okay, I'm going to write it, and I always write in English, just me. So what's the probability that one is too tight? Now, X is the number of successes, so I want at least one successes, right? That's what I want. At least one success. But now here it is. There's that at least one, so what I do is I think opposite. And when I think opposite, it's always that 1 minus. Okay, so here's the opposite. The probability is 1 minus, okay, think opposite. 1 minus the probability of, now what's the opposite of at least 1? The opposite of at least 1 is none. Make sense? The opposite of at least 1 is none. All right, but now this is 1 minus the probability that X equals 0. So on my calculator now, I'm going to get this. 1 minus, now I'm going to try to get this. 1 minus binom, now it's exactly, right? I don't have a collection in here. You might think binom CDF, C for collection, but I just have a single one. Just one, precisely, so P, binom PDF, just precisely 1, 0. So I want binom PDF, and I want, what do we have? 20 people, 0.1, and I want a 0 here. So here's how we're going to do this on our calculator. I'll do it at the very top here. Type in a 1 on your screen, on your computation window. Type in 1 minus. Now what we have to do is we have to get this down here at the bottom. All right, so we're going to go to second vars. All right, so I'll put it in here now. Here's how we're going to do this. We're going to put in all of this. All right, so you got that typed in now. You got it typed in as 1 minus. Now, what do? You got 1 minus. Okay, I'm going to do it as we do this too. All right, I've got my calculator out and ready. So I typed in 1 minus. Then I hit second vars, distributions, right? I scroll down to A. That gave me this. I press enter. That comes up on my screen. So my screen now comes up to this right here. So put in 20 trials, arrow down to 0.10 or just 0.1 if you like. The X value is 0, and then paste, enter. So here's what's coming up on my screen. You can't really see it because it's way off to the right. But what should be on your screen is this. 1 minus binom PDF of 20.1 and 0. Now on my screen, all I can see on my screen is this part right here. Okay, that's all I can see on my screen. But I'm going to believe it's there, and then I'm going to press enter. All right, so I'm going to press enter. Oh, that blue doesn't really work, does it? So I'm going to press enter and have the calculator perform that computation. So I press enter, and I got this. I got 0.87842, so on. I'm going to round off to 4 places. So how about this? The probability of getting at least one tie that is too tight out of these 20 people, getting at least one tie that's too tight, 0.8784. So about 88% chance that that's going to happen. Now in part B, we're asked for the probability of getting more than 2. All right, more than 2. Well, to get more than 2, I'm going to have to accumulate from, all right, what is more than 2? 3, and so actually, here's what it is. I'll write this out because I always do it like this. More than 2 means this. X is greater than 2. Or, if you like, more than 2 means X is greater than or equal to 3. Now, that would mean if I did it individually, X would have to equal 3 or 4 or 5 or dot, 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 or all the way up to 20. All right, now that's really cumbersome. So what I'm going to do is this. I see kind of an at least in a way, I see kind of an at least, more than, okay. All right, what's the opposite of this? All right, so what I'm going to do here is I'm going to think opposite. All right, so I've got all these listed down here. 3, 4, 5, 6, all the way up to 20. All right, what's the opposite of this? Well, what's left over? As soon as I think opposite, it's going to be 1 minus the probability. Well, what's opposite? X could be what? What's opposite? 0 or 1 or 2. Make sense? I want from 3, 4, 5, all the way up to 20, but think opposite, because the calculator will compute, it will accumulate, but it always starts at 0. It doesn't start at your number. It'd be nice if it started at 0 and accumulated to 20, but it doesn't. So I have to force it somehow. All right, so I have to think the opposite. So the opposite of 3 or more is 0, 1, or 2. Okay, now what is this going to be? This is going to be, all right, let's do it up here. Well, what I need now is this. What we need is, I'll do it at the very top, 1 minus binom CDF, right, because I'm going to accumulate. I want this, and I want this to be, we have 20 trials at 0.1 success, and I want to go up through and include, what do I want? 2. 2 is my very last number, right? So I'm going to go up to 2. All right, so how do we get this? Well, we know how to get it. Actually, two things here. We just did it down here. Yeah, so what we're looking at is, here's what we want. 1 minus binom CDF. I want CDF. Now, here's what we're going to do. We're going to type in, I'm going to do this in red, so I'm going to type in 1 minus, and then what do you do here? Now you have to go to second, VARS, and the VARS, remember, is really distribution, all right? And then you scroll down to B, all right? You scroll down to B. Now B is this one. It's binom, I can't spell it, binom CDF, right? You want C. That's the one that you want. And then what comes up is, on your screen, you see the binom at the very top, binom CDF, and then you get trials. All right, so trials. We have 20, because there's 20 people we're going to look at. P, probability of success. The probability of a tie being too tight is 0.1, or 0.10 if you like. Now the X value, right, the X value, what are we looking for? Well, we're accumulating, so you will look for the highest value. We're going to accumulate from 0 to 2, right? The CDF is an accumulator. It starts at 0. That's why we had to go back and think opposite. So 0 to 2. So my value here is going to be 2. Then I go to paste and press enter. Now, when I press enter, this comes up on my screen right here. Now, I can't see all of it, right, because it's just too long. All right, so I can see, like, from the O out, I can see that. So I'm just going to hope that the 1 minus, that I remembered to type 1 minus. I did 1 minus up here at the top. I did 1 minus, and then I did all that. So now press enter. When I press enter, this comes up, 0.676926, dot, dot, dot. So round to 4 places, I'll get 0.6769. Now, what is that? That is the probability of more than 2 ties too tight. So the probability of more than 2 ties being too tight is about 0.6769, or if you like, about what? 68? So there's about a 68% chance that out of these 20 people, at least 2 of them are going to have ties that are too tight. Now, part C says, what's the probability that no tie is too tight, right? No tie is too tight. I'll write it in English. This is going to be the probability put in terms of x's. I want no successes, so x has to be 0. So now I'm going to go get this. I'm going to get binom PDF. Now P for precisely 1. And I'm going to type in this, 20.1 and 0. All right, now how do you get all this? You get all that by, doing all this. Second, vars. All right, so what are we doing? It is second, vars. All right, then you scroll down to A, which is binom PDF. All right, and then you're going to put in trials 20 P 0.1 X value 0. And we are going to get, when I do all that, when I do that and press enter, I got this. The probability that x is 0, that nobody has a tie on that's too tight, is 0.1216. I'm rounding it off. So there's about a 12% chance out of these 20 people, nobody will have a tie on that's too tight. Now there's a part D. I'm not going to do part D because I think we're all worn out.